Okay, here we go. All right, so did I cut that right and paste it? We're just doing a couple things here in class. We already did this one. If you wanted to know, good FOILers, good factors. What's sine squared plus cosine squared 1? Oh, I forgot to highlight that. You don't need highlighters in your, when you're doing your identities. I'm just trying to, show you what I'm logically expecting to see. Stickler math teacher might have you add an extra step and shove these two together and then say they're one. I think even underlining like this and then underlining that, if you don't have a highlighter, would be a way. Doesn't that seem reasonable? To do that, just say yes, somebody. Okay. And then, I'm highlighting the differences. I guess I would highlight that. And I just told him I can't help you if you can't recognize from the sheet what these identities mean. This whole gosh dog chapter is just substitution. Did you notice that? Isn't that all I did right there? I mean, I did some algebra, but then after that, it's substituting by, what did I tell you? Try to beat in your head, memorize the 5-1 things. And then I tried to beat in your head a couple other things, and then we kind of veered off, and I gave you that little quarter sheet. And you have that quarter sheet in front of you. So I really question you, and I got really, really, really not nice, I guess, to make it in a nice way, for anyone that did nothing on this question. Because I really question that. I really do. You have the quarter sheet in front of you. The first thing you should have done is at least this. And by the way, I actually opened a book yesterday. I literally opened this book at the end of the notes. Where's the book? Where is it? Where? Right here. And I go, hey, by the way, on this one, do you remember me doing this? Well, did I dream this? Didn't I do this? Right. And then I said, you better just do something. Oh, and then this one, notice when I'm done, I'm supposed to just have cotangents. So apparently this one disappears. So now it's time to look at your sheet. Good, I'll do that. Look at your sheet and look at cosine of 2x. Is there one of them with a -1 in it? Yes or no? Yes! And that's what I said. I said, choose the one that looks like it gets closer to the right side. So, okay, we'll do the highlighting thing again. There's that change. And if you can't recognize that from looking at the formula sheet, I'm done. And then the other one is, this is the one with -1. I believe it's 2 cosine squared of x -1, correct? Yes? Okay, because sometimes I'm not perfect and I don't have them totally memorized. But then I'm like, okay, all right, so if I choose that one, if I choose the other two, then I'm in trouble. If I choose the cosine squared minus sine squared, it doesn't do anything for the right side. The one's still there, and I have a big, huge mess. I don't even know where to continue. I guess I did. I have an idea, actually. Did anyone stick with me on that? Just imagine with me. So if I change that to cosine squared minus sine squared, and I have 1 over here. Hey, by the way, what's 1 minus sine squared? What's 1 minus sine squared? What's 1 minus sine squared? Cosine squared. So then you'd add an extra step. That's what you would do. You just added an extra step, though. So I guess it's okay. You would just add an extra step, and then we'd end up at this position. You cancel the ones. I'm glad I just thought about that. You wouldn't be dead. You wouldn't be dead in the water. You'd be. You just have to. You continue. Just keep swimming. Just keep swimming. What movie is that, everyone? What did you say? Oh, I thought you said. I thought you said it's something different. I don't know. All right, and then hey, what happens to the twos? I probably shouldn't do that yet, because what order did I do that, right? So let's write the twos and then cancel them here. Then we can do the canceling here. And then those that don't show work. Some people are ahead, and then they and then they do 2 calculated things in their mind, and then they just write the third step. You're gone. This is all about showing your steps and showing your logic to prove. And I do have some sitting here that do that. So we got these different levels of students, and some don't want to show their work. Some really do, and they do well, and then some we don't even get started. And I can't do it anymore. That's where I'm done with those that are not getting started. Every single day, it's hard to keep going when we're stuck on previous stuff. And then now I do have cosine over sine, which is cotan, and therefore that's how this ends. So I've done two so far. I did scroll up here for those that are sitting at home. Um, you could pause and look at that work, and it actually should mathematically make sense. The fact that it doesn't, I don't know. I can't do it. For 45, perhaps you want to get nuts. Let's get nuts. And you pick something. You should actually pick some others. There are some things that I fell short on yesterday. Okay. Who looks more complicated, right or left? It's left for sure because it's I cannot turn theta into 2 theta. I have a sheet here that has identities for these that converts 2 theta trig to theta trig, right? And that's what is 2 theta and theta? Hey, if theta was 70 degrees, what's 2 theta then? 100, 140. That's it. It's all it's saying. There's a relationship between an angle and when I double it, and it's in these formulas, right? And that's what's happening here. I could literally compare cosine of 30 and cosine of 60 through a double angle formula, and that was with that you would get an answer. By the way, what's the cosine of 30? Everyone should know that answer in a second. Root 3 over 2, and if you don't know that, what's sine of 30? 1/2. What's tangent of 45? That's one of the easiest ones in the world. What's tangent of 45? 1. These are also the ratios from chapter 1. Lie. Chapter 2, 3, a little bit of 4, and now they're back in 5, although it's not in this question. All right, so you do something, not nothing. Yet again, I have no choice on the bottom. But now look at the top. Okay, I don't have the same simple right side, and this is what you have to do with an identity. You have to keep looking at the other side. Most of the times, it feels like we deal with the left side, though. It seems kind of how they construct them, but it doesn't always have to be. All right, so I got a minus sign. 2 of the cosine 2 thetas have a 1 in it. No trig. It's either 1 minus 2 sine squared or 2 cosine squared minus 1. And 1 over 2 trig things doesn't turn into any of these. So I did actually tell you as a hint, you should try this one. Go ahead and look at your sheet if you think I'm an alien. Where did I come up with this? This is literally what they say cosine of 2 theta is equal to. All right? And then this is what sine of 2 theta is. You don't need highlighters for identities. I can look at your logic and say, yep, the student knows how to replace. The student knows how to, this is equal to this, so I can substitute. That's what this whole chapter is about. Okay, now what? I did this off to the side. Everything is related to grade school. This is why I'm a fraction jerk. You're a jerk in many different ways. I don't care. Isn't this true? Of course, what would that become? What would that become? 4 over 7. But wasn't that true how that's written? What I'm going to do is this. I'm going backwards. So that's what we need to understand when I write the next thing. I'm taking something that has a common denominator already and splitting it up into 2 valid fractions. It is grade school what I'm doing next. It just doesn't look like it because there's trig. Oh, by the way, we are ready to cancel those 2's before I do that. And then step 2 would be this. Cosine squared. I should have done minus. Same thing with minus as in plus. Sine theta, cosine theta, then a big fat minus. And that's why I did this, because I have a big fat minus right there, and maybe something will happen. You already have this done as you're taking a little siesta over there? Sine squared. This is an actual literal assignment that you should be writing down before you turn it in. Equals. And again, the structure for the equal sign is you're telling me, you know what you're telling me with this equal sign? Yes, Mr. Samuels, I keep looking at the right side and I know I'm trying to accomplish that. Right? That's what we're doing with that equal sign. And then the steps are just so we're structured and this is neat and not messy and not all over the place. These have to be in order, step by step, right below each other when it's proving an identity. And then I think you can see it's over. But I do have to keep seeing the right side though. So I got to shrink this down a little bit. Cosine squared with a cosine. I'm okay with that. If you want to put a little to the first after that, that's fine. Sine with a sine. And that's to the first power now. Oh, cosine over sine is cotangent. This is why you have to write it. Because do you know how many people still can't tell me that? There's a few. All right. And that's from section 5.1. And this is what wrong. Sine over cosine is tan. Oh, correct. I did literally exactly turn in the right side into the left. Wrong, left side into the right. Okay, so now another one I should do. It's either 9 or 11. Ah, I keep hitting the wrong thing there. Yeah, there's my face. Where's the book? Oh, there we go. Here's what I didn't do for you yesterday. This one you can yell at me. I didn't give you an example where it was in reverse order. Not 11. I think 11's okay. And it's so weird that they didn't do tangent questions in the homework. I don't know what I missed there. I don't know if maybe it's accidentally in section 5.6. I don't think so though. I don't know, but they didn't even ask tangent questions. So you know what I'm going to do? I'm going to do tangent of 2 theta of this because I know tomorrow, wrong. When's the test? Thursday. I ask a tan 2 theta question. You might run into having to deal with fractions on this. So here's number 9. No, 13's fine. By the way, 2 over what? 1. And then you use the Pythagorean theorem. So it's just you may have just let that get you. This is 2 over 1. By the way, where's tan positive and cosine positive? What quadrant does that have to be? 1. No, that's 1, right? They're both positive in quadrant 1. So that one's a flat out, that one's actually like my notes. Paste. This one not, though. I didn't go in reverse. So, and then I first noticed this when someone came into Compass. It's great. Someone did, and I'm like, you know what? You're right. I made a little boo-boo there. So then I did actually keep this in the review today. So here's the problem with this. First of all, we have to find sine. I don't like how they do the directions, but this is what they're asking. This is what you were supposed to do yesterday. I guess no, I'm wrong. I think I'm wrong. I can't do that on this one. Yeah, I'm throwing myself off on that. No, I think I'm fine. I'm fine. Yes, I'm fine. Let's do tan of theta. Let's find tan of theta. No, actually, I did screw that up. Let me see. Now, yeah, I'm getting myself all jacked up. I know what I did. Never mind. Okay, but this is the one that we didn't do. Okay, sorry. Good thing I have this on the tape. So let's do what they ask you here first. Okay, so let's go ahead, first of all, and determine where is theta. Well, we should know that right away. What quadrant is theta in? What quadrant is theta in? Come on, guys. Don't let me jump out the window again. It's in quadrant 2. Okay, pi over 2 is 90 degrees. Pi is 180. Between 90 and 180 is our quadrant 2 and our ASTC thing. So sine should be positive and cosine should be negative when we get these two answers. Got it? Okay, so now this is how you can go ahead and do this. Let's find sine first. Look at your formula sheet. What does it say cosine of 2 theta is equal to with only sine in it? What is it? Come on, let's all do it together. Say it. 1 minus, anyone? 2 sine squared. Here we go again. We have yet another substitution. Oh, wait a minute. I didn't show this in notes yesterday, and I'm admitting it. But if I do that, then all I have to do is solve this equation. This is all I have to do. Okay, then you end up getting what sine of theta is equal to. We do have a plus minus thing going on after that. And that's when we make our choice that we choose the plus. All right, I'm going to subtract 1 from both sides. No, I'm not. Yes, I am. But I'm going to start my grade school. Subtracting 1 is subtracting 12 twelfths. And then I have a common denominator. Again, don't tell your friends that trig is hard. It's fractions. That's all it is. Fractions, fractions, fractions. Next thing, divide by -2. That doesn't work very well with fractions. So I'm going to multiply both sides by -1/2. This is stuff I've done all year long when I've shown like working out stuff by hand without touching our calculator, right? And then this is why wax on, say it. Wax on, say it. Wax off. We're supposed to be pros at this stuff at this point. Really, really, really are. Negative times a negative is a positive, thank goodness, because I can't be taking the square root of a negative. And then 2 times 12. That's how you multiply fractions, which I've been showing that since August, off and on throughout the year. Now this is where it gets a little ugly. Square roots. Okay, well, when I get this figured out, I'm done. By the way, what's 24? What times what? What times what is 24? 2 numbers. 6 and 4 is the best. What's 4? Square root of 4. So in the top, by the way, now it is plus minus. But because we're in quadrant 2, we choose the plus. This is kind of a tougher thing here. And then square root of 17 over square root of 4 is 2. 2 root 6. At least I only have to rationalize the 6 now. And then this is math 2. Multiply top and bottom by root 6. That becomes 60 and 42, which is a square root of 102. And by the way, why I know that doesn't simplify, 17 is prime. 6 is 2 times 3. There are no perfect squares in that broken down product. That's great. I just put it all underneath a radical then, and I don't have to simplify. Down here, root 6 times root 6 is 6. 6 times 2 is 12. All right? Now, to be honest with you, you have sine of theta now. Do you know how you could find cosine of theta? You could change this to 2 cosine squared minus 1. Or, please go. I'm in the middle of a movie. See ya. No more walking in my room. Goodbye. He should have known I was crabby today, that I wouldn't like that. This is what letter for theta? What letter is that for theta? It's a chapter 1 question. What letter does that represent? Whoa. Why? What letter does this end up being for theta? R. You know how you can find x real quick? Pythagorean, anyone? Theorem. So I actually showed this to last hour that now that I have some information about theta, I could find all the other information for theta without having to go through all that again. What you really could do is now find x. By the way, we should be quick on this. It's this squared minus this squared, and then the square root of that. That's the Pythagorean Theorem super fast in action. That's 42. 42 is 2 times 21. 21 is 3 times 7. Is there any perfect squares in 42 at all? No. That's actually a good thing. By the way, what did we say cosine was supposed to be? What kind of number? Negative. So square root of 42 over 12 is what the cosine of theta would end up being if I did this the long way. But that really, once you get sine of theta, you can go back to chapter 1. This is what exactly the kind of question we did in chapter 1. This is building blocks. This is wax on, say it one more time. Wax off. But if you didn't ever wax on and wax off, then you you can't proceed on. All right, we can't remember this stuff and make it easier for ourselves. So I just try to do that with this stuff and make you understand that. Here's what I want to do. This is where I was getting myself all jacked up. I hit the wrong thing again. Come. Oh, here we go. Which one did we do? We did so that was 9. Maybe I did 12. I want to. You know what? I'm going to cheat. I'm going to look at my notes for my other period and see what one we actually did. No, that's that one. This one did this one. Did 2 9? Yeah, I did that one. Did the 15. Let's do 15. Right, I did it again. I hit the wrong button. I'm driving myself nuts. 15. I did this one, but you know what I did on this? I did tangent. Even though they didn't ask me for it, I did it. I did tan of 2 theta first, and I want to do it again with you guys. So go back to your little note sheets, go back down to the bottom of this extra stuff that I'm doing, and then put 15 here, and then understand these cryptic directions. Okay, by the way, where is, and understand this again, this is theta information. This is theta's all what theta has going on for it. See how they all say thetas? And then from that, they wanted you to find sine and cosine of 2 theta, but I'm going to start with tan. I'm going to show you something that you'll have to do maybe on your test on Thursday. Okay, by the way, where is sine? Where is sine negative? And what does this say about cosine? Positive or negative? 3, 2, 1, go. Positive. What quadrant would that be? 4. C, all students take calculus. Cosine is the only positive in 4. So here's theta. If you needed to draw it again real quick, this is why I said drawing triangles is going to be the domination of this chapter. Wrong. Domination of this semester. This is coordinate trig, so you have a coordinate plane with triangles in that coordinate plane. Sine is opposite over hypotenuse. Okay, and then quick with the Pythagorean theorem. What's 7 squared, everyone? 49. What's root 5 squared? I ignored the negative because negative squared are positive. What's root 5 squared? What's 49 minus 5? 44. What's the square root of 44 broken down? What times what equals 44? 4 and 11. What's the square root of 4? 2 root 11. So this is theta information. This is what theta has going on for its values. How does that help me to find tan of 2 theta? Look at your sheets. Here's the conversion from 2 theta to theta. It is, I'm having a mind blank. Is it 2 tan theta up on the top? And then is it 1 minus tan squared on the bottom? Well, how do I fill this in? I go to my theta triangle and fill in those values from there, from chapter 1. All right? So 2, okay, this is where you want to get nuts. This really does get nuts. But I don't care. At this point, you substituting the values in here, you got 2 points out of 4. All right? You going in and understanding how to deal with these formulas and put in the things in their place, which I do believe is part of the problem, like formula usage in general. What does it mean to use a formula? And how do I plug in the parts? That's what we're testing you on. And once I find this is not actually that hard. Meaning I don't have to reevaluate. This goes in 2 different spots. Okay. The only thing I really can do up in the top is what? Please tell me what happens with the 2's up in the top. What happens with the 2's up in the top? Cancel. Again, it's fractions. It's very, very, very rough. Don't lose that negative and leave it alone for a second. I know we have issues up here. Let's take care of the issues on the bottom. And I'm not writing 1 yet on purpose, but I'll go ahead and write the minus there. Okay, everybody, how do you square a fraction? You square the numerator, square the denominator. What's root 5 squared? I'm ignoring the negative. What's root 5 squared? 5. Let's break this down. What's 2 squared? 3, 2, 1, go. 4. What's root 11 squared? By the way, wasn't the square root of 44 2 root 11? So when I square the square root of 44, what do I get? 44. We just got 44 anyway by what I just did there. So what am I going to write as 1? I'm going to write it as 44 over 44. This is grade school. Do not tell your friends that Cat is this dominating, tough. They just ask you to do these ridiculous things. You're wrong. You're wrong. You need this, right? And I knew it. It's not just because of these stupid questions. We had some fractional stuff in our identity stuff. I lost them. I'm way off the board here where I wrote my work here. Anyway, boom. So I probably should change this up here. Okay. Now, what did I say a fraction divided by a fraction is? It's a fraction times, anyone? Reciprocal. Maybe we're getting some people on board here that these fractions are not that big of a deal. All right. And then, okay, it is a little bit ugly now. Now what do? I do have this radical in the bottom. So let's do our rationalization of a fraction, which is multiply top and bottom by that bugger that's down on the bottom, the thing that's causing this issue. All right. Do not take 39 times 11. Leave that. Root 11 times root 11 is a free 11. I think you can see why I do that. What's going to happen with that 11, by the way? Look up in the numerator. Who's the 11 going to hit? Who's 11 going to go into? Why did I just write 11 off to the side? Well, who's 11 going to go into up on the top? Please tell me the number. 44. So I'm going to write 44 free out in front. And then root and a root. Sorry, we do have a negative. Don't lose that negative as a product. And a root times a root is a root of that product. And by the way, those are 2 prime numbers, so nothing at all comes out. And now I can see, oh, okay. And now I can write my final answer in a clean format. Negative 4 root 55 over 39. This is not at all what you had to do for this number. I just thought I would go through that process one more time. Will it be this bad on a test with these double roots? I doubt it. There might be a radical somewhere that you have to deal with here. But this is stuff we have done before and you've done in Math 2. Now let's do what the actual book says, and this should be in your assignment. What's sine of 2 theta? Look at your sheet. We've actually written it 3 times today already, I believe, if not more. It's 2 sine theta, cosine theta. This one's way easier. Sine theta, well, I have that. That one I didn't have to do any work on. That was given. So I get to put that in its place. This is where I really see people that don't have an idea what's going on. If you put the word sine in front of this, that really shows you don't know what's going on. You sine an angle and it equals a ratio of sides. That word sine should not be there anymore. This is just thinking out loud what I see students write when they're doing these things. That's actually a chapter 1 problem, if we're still doing that. And then times. What's the cosine of theta? We have to go up to our triangle. What is the cosine of theta if that's theta's triangle? And the numerator is 2 root 11. What's in the denominator? 7. And then this is where I was a little crabby yesterday because I think it was 0 for 3 all day long. What does this become? All right. This is 2 over 1. So 2 times all the way across. That almost looks like a pi. I just noticed that. 2 times 2 is 4 with the negative. So 2 times 2 times a negative, negative 4. Again, root 5 and root 11, root 55. And now, oh, this is done. 1 times 7 times 7, 49. Done. Okay. Hasta la bye-bye. And then what do I do for cosine of 2 theta? Well, I think you'd be smart to choose one of the 3. What do you think the smartest choice would be? What was given? What was given in this question? Sine or cosine? So what do you think the smartest one would be to choose in case you made a mistake on some other stuff? 1 minus 2 sine squared. You don't have to, but since I have 3 choices, choose wisely. You have chosen wisely. That's from Raiders of the Lost Ark. What's the third one called? I can't think of that. The Last Crusade. Sorry, I was trying to remember which one it was. That's where I stopped, and it is The Last Crusade. Is it wisely or well? I might have that word wrong. Well, no, that's when the guy dies. I'm talking after when Indiana Jones chooses well or wisely. Anyway, what's root 5 squared? I'm ignoring the negative because negative squares are positive. 5. What's 7 squared? I almost said it. So this is 5 over 49 in parentheses times 2. And then you know what I'm going to do? I'm going to make one 49 over 49 just to speed this up. What's 2 times 5? What's 2 times 5? 10. What's 49 minus 10? 39. Now watch how this all kind of meshes out. And then this is where I got happy that I was a little nervous on when I decided to do tan 2 theta first. I like that answer looks really weird. But now I know I'm good because you know what sine is? What letter over what letter? What sine? What letter over what letter? Y. And then what's cosine? What letter over letter? X over R. Huh? And what's tangent? Y over X. Do you see how it all ties in together now? Any other questions? I'll do the whole homework for you if you want. Okay, then I'll do what I did here. He's still blabbering. Oh, I went to the review and I personally picked to change what I've done in the past. What I have to do is change the key though. And then we'll start putting the key there. This is 5-6. This is what we didn't do. I like these things. A sonic boom from a plane. You can explain that stuff through trig because sound waves are waves, right? Remember the sine graphs, waves? Did you know AM? You guys, who listens to the radio anymore? Not Sirius radio, the radio. Nobody. Do you? I do too. I still 100.7 hard rock. I'm banging my head off the dashboard as I come in, and I come in all fired up and ready to go and teach teenagers. AM means amplitude modulation. That means it's a longer wave. If you travel far, your AM station stays with you longer. But that's why the sound is not as crisp. It's like it's not as then when you go to FM, it's a very crisp sound, but you'll lose that because that's frequency modulation. It's a shorter wave, but that's why with a shorter wave you get a crisper sound. Isn't that amazing? That's something. All right, anyway. Oh, there's a picture of a train. I choose you. That's from if you know where that's from. That is from The Simpsons. Nicely done. What episode? What were they celebrating? Valentine's Day. Ralphie gets a Valentine's card from Lisa. Anyway. Now I lied to my fourth hour. 15, do not find all 6 trig functions. Just find the first 3. Sine, cosine, and tangent. Here's how. What's 165? An angle, a number. But what plus what equals 165? And therefore we could use our sum identities. 135 and 30. That's not the only option. There's more. 120 and 45. You can do sine of sum, cosine of sum, and tangent of sum using those formulas and then go from there. So that's why you can do that. I literally said only do 16A. Do not do B because we did not do half angle identities this year. We just shut it down. Then when I go to the matching, by the way, I did this yesterday with your homework. This is why I do this to kind of help you get your mind in the right spot. This one right here is invalid. This is a half angle identity. But notice it's the only one that looks like that, right? So in matching, you can do a process of what? Elimination. So that will be the last one that you match. Does that make sense? That's why I don't feel guilty about eliminating the one that actually equals. You know what you have here, though? I bet you have like maybe some co-function identities. Remember sine of 30 equals cosine of 60? It's possible that that's what's going on there. Maybe what's going on with that one. This one should be easy. Which one's cosine minus sine? Is that a cosine or a sine identity? Which one? We actually tested you on this. That's a cosine. Is it a sum or difference? Cosine to sine is different, right? So you're getting, and then what's this one? This is how this is easy. Process of elimination. Is this a sine or a cosine sum or difference? Sine sum. So you can do those two right away. We literally just talked about these today. This one should stick out like a sore thumb. Which identity this one is. Same thing with this one. This is how you do a matching. You look at the ones that you might want to go here and then match backwards. That's what I would do probably, because I think that's really how this works. At least how I start. I would do this one go backwards, this one go backwards, this one go backwards, this one go backwards. Choose which ones they go with, and then go from there. 1, 2, 3, 4, 5, 7, 8, 9, 10. Yeah, there's 10 of them. 10 for 10. All right, and I think that was half of them. Then we'll see how it goes after that. I had to eliminate these because in this section with the sum and difference identities, we didn't do these types of questions. I did incorporate 33 again because I literally just did a question like that today. You change cosine 2 theta into 1 minus 2 sine squared theta and solve. This one is like I did in the notes, so I did do 35. And then I think I skipped to these. I skipped to 49. I really shouldn't do this, but I just feel like having these discussions right now and finishing off the video. Which side looks more complicated? Aren't they a tie? So one person might work with the left side, one might work with the right. What does this side have that this side does not? What trig function? No. What does this side have that this one does not? That is cosine squared. Is there a way to change this into a cosine squared? See, now everyone in this room should say yes immediately. What is sine squared equal to? Somebody that knows, please raise your hand. 1 minus cosine squared. That's the substitution. By the way, what's the substitution for this as well with the minus sign in parentheses? Say it again. 1 minus cosine squared, but of y, not of x. And then you do some algebra. 49 is easy. And then I had a debate. What did I want to do, 52 or 54? I went with the one that was a little bit more challenging. Like, for instance, I like this feature. What's sine to be or not to be? That's the question. What's sine to be? I was mad at my joke. I was being a student. I turned into a student. I hate his jokes. What's sine to be? 2 sine b cosine b for the 5th or 6th time today. Okay. And then I got fractions within fractions. What's tangent of b? Go back to section 5.1. Sine b over cosine b. And then what is dividing by a thing? Multiplying by its. That's how you do number 54. By the way, this makes me sick. This makes me want to jump out a window. Good thing I'm on the first floor. Is 2 tan b equal to 2 sine b over 2 cosine b? True or false? Everyone's scared to answer. He's going to yell at me because of fractions. What just happened to the 2 when you put the 2 in the numerator and the denominator? It canceled. Could that possibly equal the left side? Where does the 2 belong? Where does the 2 belong? In the numerator. This is horrible math doing this. No, seniors, no. Have a good day, everybody. By the way, remember from Carl Sagan that we all come from star stuff.